Okay, everyone, so if you're watching this, then you feel comfortable with the first derivative test, and you are moving on with the second derivative test and kind of working on your own today. So the first derivative test told us when a function f of x was increasing or decreasing. We use the derivative to say that when f prime of x was greater than 0, our function is increasing. When f prime of x was less than 0, our function is decreasing. And a maximum occurred when we went from positive to negative, and a minimum occurred when we went from negative to positive. So all of that information is what the first derivative tells us. There's another feature of f of x that we are going to discuss, and it's right here on this function. And we call this a point of inflection. So the point of inflection is actually where the function changes concavity. So this definition, this word, concavity. So we can either have a part of this function that is concave down, so something like this would be concave down. And we see that on our graph here that this portion of the graph is concave down. Or we could have a function that is concave up. And we see that on this piece of f of x, our function is concave up. Excuse me. The point of inflection is where that function changes concavity. And so to find that point of inflection, that's what we can actually use the second derivative for. So here's our official second derivative test. So second derivative test says when the second derivative is greater than 0, f of x is concave up. And when the second derivative is less than 0, f of x is concave down. If f prime of x changes sign, then a point of inflection exists. So those three things are what we use the second derivative to find on f of x. So let's do that algebraically. So we have a function here, f of x is negative x cubed plus x plus 2. So we're going to use the second derivative test to determine when is this function concave up, when is it concave down, and where is the point of inflection. So first I want to find my second derivative. So f prime is negative 3x squared plus 1, meaning the second derivative is negative 6x. So same as what we did with the first derivative test, we're going to do a similar process with the second derivative test. We're going to find those critical points or where the derivative is equal to 0. So setting this equal to 0 and solving, we get x equals 0 as our critical point. So we're going to make a sign chart. And this is a line that has a negative slope, so it's going to be something like this, meaning in this interval we will be positive, and in this interval we will be negative. So the second derivative tells us that f of x is concave up from negative infinity to 0, and that is because the second derivative is greater than 0, and f of x is concave down from 0 to positive infinity, and that is because f double prime is negative. We have a point of inflection at x equals 0, and that is because f double prime changes sign. All right, and there's the second derivative test. There are 2 other videos that go over specific examples, and those are optional for you to watch on your own time.